One thing's for sure, the Earth is a water planet. About 3/4 of the Earth's surface is covered by oceans. In addition, water is the origin of all life on Earth. But it is still not clear where all the water came from. Was it delivered through impacts of comets and asteroids on the young Earth? At least that's the current theory. But now there is a new, super exciting approach from a US research team, and the Sun plays a decisive role here. According to this, the solar nebula could also be the origin of Earth water. Find out how exactly this could have happened and why this makes the existence of extraterrestrial life much more probable. Now on Clixoom Science Fiction, watch exciting science videos 3 times a week and subscribe to the channel. Only then you won't miss a thing. Welcome.
1, 2, 3.
So far, it is assumed that asteroids and comets brought Earth's water with them when they hit the young Earth. The chemical signatures indicate this. Ocean water and the water on asteroids are very similar. This theory is thus accepted, although there are mysterious discrepancies. For example, the gigantic water reservoirs in the deep interior of the Earth. The rock there stores at least twice as much water as all the oceans in the world, and its signature does not really resemble the water of the asteroids. In concrete terms, it is about the concentration of deuterium. It is significantly lower in the water of the deep mantle than in asteroid water, similar to the water-rich comets, which also do not really fit into this picture. The Rosetta spacecraft has revealed that the isotope signature of comet water does not correspond to the signature of the earthly oceans. This means that this theory cannot provide a comprehensive explanation for what happened on the young Earth at that time. And so research teams all over the world are constantly tinkering with the one exciting question: how exactly did the water reach Earth? A new exciting approach is now coming from a research team at Arizona State University. They want to extend the old theory and refer to the Sun, or more precisely, to the solar nebula. According to the scientists, this was probably the predominant reservoir for hydrogen in the early solar system. Nevertheless, there is a discrepancy which again refers to the deuterium content. Solar hydrogen contains far too little deuterium to actually supply the ocean water. But the US team has an explanation, and it begins very early, when the primeval Earth was covered by a magma ocean and surrounded by a primeval cloud. This attracted gases from the solar nebula, forming a first Urate atmosphere rich in hydrogen. This bound to the iron contained in the magma after it had separated from the glowing rock. As the Earth layers formed, the iron sank into the Earth's core and took much of the hydrogen with it. And now pay attention, the Earth's crust solidified slowly, and the water accumulated in it and in the mantle with deuterium. This was due to the fact that deuterium had a smaller affinity for iron than normal hydrogen, and this led to a separation of the isotopes. Further water was brought to the Earth's surface by the impacts of comets and asteroids, and the oceans were formed bit by bit. The US research team tested their new theory in simulations. We calculated how much hydrogen could dissolve in the molten mantle and how much of it would have landed in the Earth's core. Then we compared these values with current deuterium contents from deep mantle samples. And indeed, even if the primordial Earth got enough hydrogen for 7 to 8 oceans from extraterrestrial sources such as asteroids, not everything comes from it. According to calculations by scientists, up to 0.5 oceans must originate from the solar nebula. In concrete terms, this means that 1 to 2 molecules of 100 molecules of earthly water originate from the primeval cloud. But the Earth has hidden this primeval water from us in its interior. 4 to 5 oceans are probably contained in the Earth's core, and the equivalent of about 2 oceans in the deep mantle, according to the research team from Arizona. The rest probably formed the world's oceans. This new theory could be tested by analyzing rocks. Not only hydrogen, but also noble gases, nitrogen and carbon, must have sunk into the Earth's interior. Let's suppose that, in fact, a long time ago, gases from the nebula in the Earth's magma ocean were supposed to have dissolved. One of the researchers involved, Yun, comments, "These gases should have left isotope traces in the chemistry of the deep rocks, which we can now search for." And you may already suspect it. This theory about the origin of earthy water makes the existence of water on exoplanets and thus extraterrestrial life even more probable. For not only the Earth, but also exoplanets could have obtained water in this way, even without asteroids. Woo! Our model suggests that the formation of water would almost inevitably take place on any sufficiently large rock planet. I find that quite exciting. And it confirms more and more the thesis that life is no exception in space, but the rule. So it will probably not be long before we encounter such life. Here on Clixoom, you will of course be the first to hear about it. Find out how much water you can see on Earth by clicking right here on Vsauce's video on the topic. Stay tuned and see you soon.